Americans. The next picture of Yuri Gagarin is him 6 years later, just before his fatal accident when his plane crashed. His body was never recovered. His wife, when awarded the Order of Lenin, the highest award in the Soviet Union, refused to wear it. The Russians have a backstory which is only now becoming available. On April the 12th, 2001, Pravda, which means truth in Russia, whether you believe they say the truth is another matter, Pravda made an announcement. They said that Yuri Gagarin was not the first Russian into space. There were 9 previous ones, starting in 1958. So the truth has come out of Russia. On July the 21st, 2009, the 40th anniversary of Apollo 11, we are told that NASA will make the announcement that they have discovered the films that were taken on Apollo 11. And we're going to see some really high-quality images. So it looks like the lies will continue. The rocks. I've got one. It's a piece of moon rock. It's quite nice, isn't it? Not very heavy, but then moon rock isn't. It's quite similar to that first one. It's like that, or possibly like that. Now, these are the Russian moon rocks, by the way. These are American. When you are asked to consider moon rock, you'll think of something like this. A piece of rock, gravel. Breccia it's called. Accumulation of melted minerals. It's not a piece of moon rock, by the way. It came from Sicily, from the volcanoes out there. Now, how would you know that this moon rock came from the moon? There's one in the Science Museum, and it says it, moon rock, so you must believe them. It came from the moon, didn't it? What about these scientists who've examined it? All over the world, 30 universities have examined moon rock. They don't get rocks like that. They get a little bit of dust. Quarter of a sugar lump size, ground up. 840 pounds of it, we're told, exist. I've never seen it. And those reports that are coming through now say that moon rock is very similar to Earth. Very similar indeed. There's very little difference. Some will say there's no water in it. No, of course there's no water in it. You can easily remove water from rock. It's called put it in a vacuum chamber. So the rock isn't conclusive evidence that anybody landed on the moon. Now the reflectors. So we hear a lot about the reflectors. This is how they measure it, with the big laser beam out of the McDonald Observatory in Texas. This is a laser beam. And it's very nice. Now, most people think of a laser beam as being coherent light, which means it maintains its shape over whatever distance you point it. No, a laser beam actually does diverge very slightly. If you point a laser beam powerful enough so it will hit something 250,000 miles away, what diameter will the beam be when it arrives on the moon? Will it be the same diameter as it left Earth, or will it be slightly wider? It'll be slightly wider. It'll be 2 kilometers in diameter by the time it hits the moon. What diameter will that beam be when it gets back to Earth? The figure normally quoted for a reflected laser beam of light is 6 photons can be collected from a dish about 100 foot across, i.e. it spreads. Now, if you're going to fire it at one of these reflectors, this is what they look like. This is the Apollo 11 reflector. This was it before it got launched onto the moon. You need to know where they are. And if you don't know where they are, you can try roughly going for where you think they should be. But are you going to be sure that you hit the reflector or not a shiny piece of rock? Because we're told the lunar surface is very shiny. No, not particularly shiny. It's about the same reflectivity as tarmac. So, do we actually know that reflectors are needed to have a laser beam fired back to Earth? No, that's not necessary. We're firing radio beams and radar beams off the moon since 1961. It's no big deal. So, Russians, no, they wouldn't actually blow the whistle because they were dependent on America for wheat as well. In the late 1960s, they'd had a drought. Americans were supplying them with wheat. The rocks, no, not particularly conclusive evidence that anybody's collected them from the moon. Could have been collected from anywhere, really. And the reflectors, not particularly conclusive evidence that there have been any reflectors placed on the moon, let alone are being used, and seeing as the budget's just about to be cut. It only costs $125,000 a year to operate the laser, and the National Science Institute have just stopped it. So that's how important it is to America. But the three things that are essential to understanding Apollo are the temperature of space, we've discussed that already, it's very cold. The vacuum of space, there is no pressure in space, that's why there's no water on the moon. The Lunar Reconnaissance Orbiter is going there, it's actually there now, it was launched last week and it's there now, and it's looking for water. They won't find it because what does water do in a vacuum? It evaporates and it just disappears. But the real showstopper of space is radiation. That's why the Russians actually gave the game away back in 1969 when they were asked through Sir Bernard Lovell, who was at that time head of the Jodrell Bank radio telescope, who was tracking the Russian craft, and he was asked to ask the Russians when they were sending men to the moon. Reasonable question. And the Russians said, we do not intend to send any cosmonaut to the moon until we can ensure their safe return due to the dangers of radiation. The Russians, ironically, are more honest than the Americans, and they did tell us what was going on. So as regards this whole farrago, this whole strange story, we're going to get some more of it tomorrow night. I'm with astronaut 4 on this one. Thank you very much indeed. I appreciate your attention.
Okay. Questions? Does anybody have a question? Yes, gentleman in the middle there. Yeah. If you could speak up, that'd be good.
Okay, sorry, I thought it was very interesting. I thought a lot of what you said about photography was a bit weak. I mean, I could think of mundane explanations for most of what you thought were anomalies, but what my question actually is about radiation, which I thought was very interesting. Now, specifically, could you give us some statistics about how, if you spend a day outside the Van Allen belt, how much does that equate in terms of, I don't know, relative to a chest X-ray, for example? How dangerous is it? Could you give us some figures on that?
Okay. The question is about radiation, and in relation to, say, a chest X-ray, what would it be like to go outside the Van Allen belts? Is that fair enough? Is that the question? Okay. I can't actually answer that because it's very hard to get reliable information. If you ask NASA, if you look on the NASA website as to what they will say about the radiation, they will say, well, the rockets went through it pretty fast. It was the equivalent of about a chest X-ray, given that they were traveling in an aluminium can. And once they were through, there was no danger, implying that once you get beyond the Van Allen radiation belts, there's no danger at all. That was the implication. The other is the circular argument that is always used in this case, which is to say, well, obviously if they got there, they couldn't possibly have been affected by radiation because they're all still alive, or they were at the time. And that's a circular argument, which says that they must have got there. Now, either they did get there, and the danger of radiation is not nearly as severe as we're told, but then how do you explain the IMAX film camera crews who were using the space shuttle to ferry the cameras and the film up to the space station to film the construction of the International Space Station in 2001? They were using the space shuttle to go up there, and they actually said we could only use the magazines unprotected for 2 minutes that was allowed for the filming, because each magazine held 2 minutes of film. Then we had to get it back into the